Good morning, student 9 class. We are going to learn the chapter Force and Law of Motion. In the chapter, we have already learned about the force, types of forces. Now we are going to learn the Galileo's experiment related to the motion and force. Before Galileo and Einstein, Isaac Newton, a philosopher, Aristotle, gave a philosophy related to the force and motion. The concept of the Aristotle is that to prevent a continuous motion, uniform motion, a force is needed. In absence of force, a continuous motion is not possible. This is the philosophy of Aristotle. He is philosopher. I think that he is not scientist. Why I am saying that Aristotle is a philosopher, he is not a scientist, because when Galileo had done an experiment, and by experiment he proved that for a continuous motion, a force is not needed. This is proved by experiment, not by philosophy. The Galileo proved it by his experiment. And then the whole world comes in a view that after an experiment that continuing motion in a horizontal way is done by Galileo, and thereafter the scientists believe that without experiment, the scientific thinking is not right. We are unable to say anything correct, 100% correct. Without experiment, it is not possible. So I have told that Aristotle is a philosopher. He has no any experimental proof for that a motion is needed a force to continue. But the Galileo proved that for a continuous uniform motion, a force is not needed. And the experiment is like this. And students, they have taken a wooden like this. It is made by wood and its surface very smooth. And the Galileo taken a glass ball, somewhere it is written as marble ball, but what is correct? It does not matter, but it is a ball having a scheduled mass, and it is also very smooth. The surface is also smooth, and he had dropped this ball from this place. It started to slide under gravitational force, which is here. After bending from here, after coming here, it goes upward direction and reaches this height, which is equal to this height. The object achieved the same height from the horizontal surface. This is if h. Then this height is also with respect to horizontal surface in h. Both height is same. It is the first case. Case 1. In second case, the Galileo changed the slope of the second side. He had changed the slope of the second side and he had made like this. The shape of this box is like this. Now, and again Galileo dropped this ball from this side, same height. But the slope of this side is greater, or the angle is greater with this surface. But this side is similar to this side, and the height of the object is same. Where it begins. When it falls, then after passing through the path, it has started to run upward and it reaches to the same height. Here, the height from the horizontal plane is h. Again, see here, what is the difference? That the slope is changed of this side and the distance covered by the moving body is extended. It is greater in respect of this box. The distance in this box is covered with this, but the distance covered in this second case is greater in respect of the first. And the third experiment the Galileans have done is like this. He have taken one side in this shape and the other end is free. There is no any obstruction, it is smooth. And when it drops here, the ball, it is started to move and continue to move for a long distance. If the slope is very greater, then it moves for a long distance. In this case, the distance is moved very higher, and the Galileo sees that if not any external force is acting on this object, then it continues to move. By this experiment, the Galileo comes in knowledge that a moving object does not need any force to continue its motion. But the Aristotle told that for motion, a force is needed. For a continuous motion, a force is needed, and it is only philosophy. It has no any scientific experimental proof. But Galileo proved it. And this is the stage where the dynamics developed. And further, Isaac Newton explored this experiment and a concept of motion was given by Newton. Here given 3 laws for the motion that are called Newton's law of motion. We are going to learn the 3 laws of motion that are called Newton's law of motion. And the basis of these laws is Galileo's experiment. With the help of this experiment, the Newton had given 3 laws which are called law of motion. The first law, Newton's first law of motion. It is based on the Galileo experiment, as I think. Or I think that I am 100% right. It is completely based on the Galileo experiment. So some writers write that the work of Galileo are further explored, read by the Newton. Yes, my students, the Newtons gave this law with the help of Galileo's experiment. The statement, here the statement of the Newton's first law. The Newton's first law say that each and every object in the universe want to maintain its state of rest or a state of motion, whether a unbalanced force, external unbalanced force, is not acting on the object. Means, if any object is in rest, this duster is laying on the table. If any unbalanced force, I am compelling you to say unbalanced force, not a force, but unbalanced force. Why I am saying, you know that unbalanced force are able to produce acceleration in a body. And I have challenged, I have gave you a task to search that in whole universe obtain an object on which a single force is acting. But I think that it is not possible in the universe that on any object a single force acts. At least a pair of force acts on any object in the whole universe. So when this object is in a static state, it means at least two forces are acting on this object which are maintaining it in the rest. It is simple philosophy, my students, and then you need a unbalanced force to accelerate it, to change its state of rest. If no any unbalanced force is acting on this duster which is laying on the table, it does not start to move. But if you extract it by a force by your hand, or if you push it by your hand, then it will start to move and drop here. What happens? You have applied an unbalanced force on the duster and then it becomes in motion. And when if your brain is moving with a bicycle and you want to ride on this bicycle, then it is the person of steering and you want to sit here or walk back here. You have asked them, your brain, please stop. But when you have not stopped, then you have applied it, pulling in the opposite direction of his motion. The direction of the motion is in this direction, and you have applied it in this direction, and your train bicycle is stopped. Here you have used an unbalanced force to change the state of motion into a state of rest. This is very simple. It is similar to the Galileo. He had told that for a motion to continue the motion, no force is needed. It means to stop a motion, just opposite a force is needed, or to change the state of rest, it is a force is needed. Now, According to the first law that anything in the universe wants to maintain its state of rest or motion, whether an unbalanced force is not acting on the object. This first law defines two different physical quantities, and that are inertia and force. The first law has two parts, inertia and second force. And second force. The first law describes the two physical quantities that are inertia and force. Then what is inertia? What is inertia? The physics describe that inertia is the internal property of a matter due to its mass, which wants to maintain its state of rest or motion. Inertia is the internal property of an object due to its mass, which wants to maintain its state of rest or motion. This is the first part of the Newton's first law. And the second part of the law describes the definition of the force. Force is a factor which can produce acceleration in a body. It is the second part. You see that whether an unbalanced force is not acting on the object. It means if an unbalanced force acts on the object, then it will be accelerated. It will change its state of rest or motion. It means the second part of the first law describes the two physical quantity, force and inertia. Force, you know very well, and inertia is the internal property of a matter due to its mass. It means inertia depends on the mass of the object. If the mass is greater, then the inertia is greater. And if the mass is less, then inertia is less. Okay, my children? If it is clear, then what are the experimental proof for this inertia or first law? You want to know, just I have described that science need a experimental proof for every thinking. For every thinking, the science need a experimental proof. If you are able to give an experimental proof, then the science accept that philosophy. Otherwise, not. Here I am going to show you, exhibit you, that how the inertia act. What is inertia? It is not possible because I have no class in other class. In next class session, I will exhibit experimentally that. I am going to draw the diagram for that to exhibit the first law. So many examples, so many phenomena that occurs in your daily life which describe the first law. First, you have a book slab where a number of books are present in this shape. The books are laying on each other, and a heap of books is made by your sister who is a housewife, and he does not understand that the books are arranged in a manner, classified manner, and was science, physics, chemistry, bio, maths in this way. He do not know. So he has made a heap of the books. And if you are needed the physics book, and this is physics, suppose this book is of physics, right, my student, and you want to take it, there is two possibilities to take it. One, you pull all these books and lay down, and then you will get the physics book. And another is, if you exert a force on this book, unbalanced force, all of a sudden, if you pull this physics, then the all heap of the upper of this physics lay down on the bottom on the heap, and the book of physics comes out. इस पर एक बैग आप झटका लगाएंगे, घूस देंगे, तो फिजिक्स का बुक आपके हाथ में, और पूरा हिप जो है बुक का, वो ज्यों का त्यों मेंटेन रहेगा. Why? This upper part of the books and this part of the books are in a state of rest, and due to inertia, they want to maintain its state of rest. And when you have applied a force on this physics book, then the physics book personally got a unbalanced force, and the physics book is accelerated, and the other books, according to inertia, want to maintain its state, and they are laying on the same heap of books. Right? A second activity of in daily life, if you take a glass and on this a card is put on, which is plastic coated, and you have put a coin on this card. Now, if you exert an unbalanced force in this card by your finger's nail, then what happens? Can you imagine? After getting the jerk or push of the force, the card comes in motion and it go away, but the coin had not got the force, energy, and so it wants to maintain its state of rest. Due to this reason, the card go away from the glass and the coin fell in the bottom of the glass. This is the next example of the first law of motion. I think that with the help of these examples, my student, the first law is clear. And in giving task, that please write 10 examples in your daily activities to solve the first law of motion. I will see in the classroom when you comes in the school. Please note the date, note the task, and solve it, and then I will see that. Now the second law of motion. The second law of motion. The second law of motion says Actually, this is the law, only second law. Only second law is actually the law of motion. But the science accept the three laws, so I am also going to accept that from my childhood, from my student life. The second law says that if you are applying a force on an object, this say, then the acceleration produced in this object A, having the mass A, the acceleration is directly proportional to the applied force. The acceleration produced in an object is directly proportional to the applied force. It means if you push, just I am going to solve this experiment. This is just and if you are applying a small force on it, then move its motion is like this. And if you are applying a greater force, then it will jump and goes there. It means the acceleration increase as the amount of force is increased, and the acceleration is less if the magnitude of the force is less. It is clear, my students. So, according to the second law, the acceleration produced in an object A is directly proportional to the F. Yes, it is clear. Now the second thing, the acceleration produced when mass is constant. Is constant. The mass, if mass will be changed, then the magnitude of acceleration and force may be changed. So the condition is mass is constant. And next, the acceleration produced in a body is inversely proportional to the mass of the object. When force is constant, in this case, force is constant. You are taking a constant force, 10 Newton. Suppose you have taken a 10 Newton force. You are applying 10 Newton force on 10 kg object, and the acceleration produced is 3 meter per second square. Now, again you are applying a 10 Newton force on a 20 kg object. What happens, my children? The acceleration is same or not? Can you say? The acceleration is less. Definitely, the 20 kg mass object cannot be accelerated similar to the 10 kg mass with the help of 10 Newton force. Same force. It means if the mass is greater, then the acceleration is lesser, and if this beast kg got 1 meter per second square acceleration. It means if mass is greater, the acceleration is lesser. If mass is lesser, then acceleration is greater. So the acceleration is inversely proportional to the mass of the object. Adding by joint variation method of mathematics, these two equations gives a variance a by m. To eliminate the variation sign, we take a constant a equal to k into f by m, where k is a constant, proportional constant. Now, what is the value of the k? If force equal to 1 Newton, mass is equal to 1 kg, and the acceleration produced is equal to 1 meter per second square. Thereafter, k is equal to 1. And putting this value in this equation, A is equal to F by M, therefore F is equal to M into A. This is the second law also. The second law can be described like this, that the force acting on an object is equal to the mass into acceleration. And from here, you are able to get the definition of 1 Newton force. When I have taught you about force, then I have not described how you define the 1 Newton force. Here you are able to describe the definition of 1 Newton force. If you are taking force, mass is 1 kg, and the acceleration produced is 1 meter per second square. Therefore, the force is 1 Newton. A force by which a, of, a force by which a 1 meter per second square acceleration is produced in a 1 kg object is called 1 Newton force. Yes, my children, this is the first way to understand the second law of motion. I have 3 ways to prove this second law of motion, and the time is going on off. I think that I have to close my session. And next class, I will prove my second method, the F is equal to M into A, then third method, and then lastly, we will conclude it with explaining it in the term of linear momentum. Yes, my children, I have told these things to warn you that please learn these things in your books, authentic books, not ordinary books. If you learn in books, then it is very helpful to learn this law. This law is very important for your physics. And thanks be beware from Corona. And my further request, please live in the home and be careful for your grandfather and grandmother. They are the first target of Corona-19 because they are above 60. Thank you. Make a nice day. God bless you.